Okay, students, let us continue again. So here, factors that influence formation of ionic bond. Ionic bond se makanda influence to the factor mayang matang do mukhanarasi. Number one factor the ionization enthalpy, electron gain enthalpy, and lattice energy. So we know that ionic bond is formed by the combination of metal and non-metal. So the favorable condition for the formation of ionic bond is that metal atom must have lower value of ionization enthalpy, and non-metal atom must have higher value of electron gain enthalpy, and the ionic compound must have higher value of lattice energy. Ionic compound seba poto higher value of lattice energy laigadabani kari maramgi compound do more stable oinaba haibane ko aduna haiba mayam se koi let us explain one by one. So first we'll explain ionization enthalpy. Ionization enthalpy se hana haursiko. So let us define what is meant by ionization enthalpy. Ionization enthalpy I will say hana define haursiko. It is defined as the amount of energy required to remove a valence electron. Valence electron is outermost single level electron. To remove a valence electron from an isolated gaseous atom. Atom is gaseous state level. Isolated gaseous atom to form a cation. Which also in gaseous state. I will see cation is gaseous state. So let me repeat it again. It is defined as the amount of energy required to remove a valence electron amaniko from an isolated gaseous atom to form a cation which also in gaseous state. Aduna ionization energy haibadi karino haiba kanda koi gaseous state leba atom amadagi outermost shell do lokthonaba honaba kanda sangiba energy do electron lokthokran kan cation semani sibu cation su gaseous state leirani aduna samsam in short ta haiba kanda koi atom amagi balance electron lokthokpala sangiba energy do koina kari kawi haiba kanda ionization energy kawi haiba ko. So let me give one example here. Example so let us remove a valence electron from sodium atom, and how many energy is required here. Sodium atom the electron am lock 281 1 later see electron valence electron ko outermost level to lock 2 siko lock 2 top kind of cation semi sodium and cation semi. See the energy change that energy is in plus la niko. The value of this energy is 495 kilojoules per mole. Haibako. Aduna 1 mole of sodium atom dagi electron ama lokthokpa kanda ma energy kya sange 495 kilojoules per mole sange. Sigi energy je akoina kari ko kanda ionization enthalpy ko webako. Aduna the value of ionization enthalpy depends upon the size of the atom. Atom is size makapole. If the size of the atom is large, it is easier to remove the valence electrons to form cation easily, and at that time the value of ionization enthalpy will be low. And the atom the size of the masagi valence electron do yamline lokthokpangamni do cation do yamline semangamni. The balance electron yamai lokthokpa ngamba haibadi energy yam sangaroi aduna ionization enthalpy value do low oini haibane ko. Aduna laiba question di why we need energy to remove this valence electron from the atom. Haiba atom dagi valence electron lokthokpada energy changbai maram karigino hai bataragati. We know that in the center atom we have nucleus. It carries positive charge due to the presence of proton. Proton yawbasina maram oiduna positive charge pure. So nucleus layeko. So this is cell layeko. The cell chocolate color. So this is valence electron color. Valence electron unico. So there is a force of attraction between the nucleus and this negatively charged electron. We nucleus ka negatively charged electron in the force of attraction layeko. To overcome this force of attraction, I have a force of attraction to overcome tong of honor kanda. Akuna kai sange energy sange ko. I have a force of attraction to overcome tong from a tunda balance no to no talk to in ko. I have a force of attraction say overcome tong of honor kanda energy sange have energy to akuna kari ko have a kanda ionizing enthalpy ko have ne. And that value of ionizing enthalpy depends upon the size of atom have ne. If the size of the atom is large, then the force of atom is size already balance electron nucleus to laptokrani. The force of attraction between the valence electron and nucleus to handarani. And the energy am sangaroi. Aduna magi ionizing enthalpy low oirani hibernate. The favorable condition for the formation of ionic bond masagi electron mang do kanano metal atom the metal atom should have lower value of ionizing enthalpy so that it can easily lose its valence electron to form cation easily haiba aduna ionic compounds yam line semi haiba taragadi metal atom dugi magi ionizing enthalpy gi value low oigadabani low oiragadi magi valence electron yam line loktuaga cation do yam line semangamani haibaneba ko. Now let me give one example here. See the alkali metal say alkali metal have the group 1 elements in say group 1 elements such as sodium gumba, potassium gumba, sodium potassium with group 1 element ko mo say yam line ionic bond semanga me non metal atom ang punsan laga ko. The alkali metal atom can easily form ionic bond with a combination of non-metal atom because this alkali metal atom have low ionizing enthalpy because of their larger atomic size. And the alkali metal say magi periodic table ta koigi mana periodic table ki sigi right hand side ta level singina kwade atomic size of the left to right kanda magi size to my size left to right upon atomic size pixel in the ko most like say group 1 element na magi atomic size to quite small ni na mo si am line na balance electron to lock thuk pangama cation semanga me ko aduna moi low ionizing energy layer aduna alkali metal can easily form ionic bond with non-metal atom because alkali metal have larger atomic size so they have lower value of ionizing enthalpy aduna ionizing enthalpy low oibanina kadawle ba kanda balance electron yam line mang cation yam line semanga me aduna ionic compound same the mono favor oi hibernate aduna last point is that in order to form an ionic bond the alkali metal in order to form an ionic bond the metal atom should have lower value of ionizing energy so that it can lose valence electron easily and forms cation easily hibernate ko si condition je oigadaba ko aduna the first condition di kadagoneba metal atom to kay legadaba metal atom first condition do ko metal atom must have kay legadaba lower value of si point si legadaba ko must have lower value of ionizing enthalpy so that it can easily lose its valence electron and forms cation easily can cation easily. So this is the condition. Niko, she fast factor later. Ionization enthalpy low oini. Hybeko. Metal atom must have lower value of ionization energy so that it can easily lose its valence electron and forms cation easily. So this is the first factor later. The second factor dong yengas ko. Second factor dong yengas. Second factor dong karino hayo kanda. Number 2, electron gain enthalpy. Electron gain enthalpy. And a higher and metal atom should have higher value of electron gain enthalpy. What is meant by electron gain enthalpy? I will define the electron gain enthalpy. I will karino. Let us define it. Define the it is defined as the amount of energy release when an extra electron is added to an isolated gaseous atom to form an anion which also in gaseous state. So let me repeat it again. It is defined as the amount of energy released when an extra electron is added. Oxide electron is added. Oxide electronized when an oxide electron is added to an isolated gaseous atom to form an anion which also in gaseous state. Samsana haibakanda koi isolated gaseous atom amada electron ama hapchalaga anion semakanda release tawriba energy to koina kari kawi haibakanda electron gain enthalpy, or we call it electron affinity. So let me give one example here. Example mapi atake muko. And here we are taking a non-metal atom because they gain electron to form an ion to get stable configuration. And you see non-metal atom mere ko. Si chlorine laure electron number loxalo kai semani chloride semen si gas state lere get stable configuration of argon phange. Sida energy release tawe ko. Si release tawu ni no minus la ni. Magi energy release tawu tadi kai la kani minus la kani. And si minus la ni 348 kilojoules per mole ko. Then the chlorine atom sina electron number loxalaga chloride around same. Sida release tawu energy se kari kawi have kanda electron gain enthalpy kawi ko. And electron gain enthalpy says simply electron affinity so high. And then just like that, electron ionization enthalpy electron gain enthalpy is also depend upon the size of the atom. Atom size maka pole. If the size of the atom is small, it is easier to take the outside electron to form an ion easily. And at that time, the value of electron gain enthalpy is high. High within an electron gain enthalpy value say high oigi have a target the atom size to pick it up. Atom size to pick the electron yam liner nucleus nits and mangamani. The yam liner and I and see mangamani. High aduna nana anion kanan semi non-metal atom and semi. The non-metal atom should have higher value of electron gain enthalpy so that it can easily take up electron to form an ion easily. This is the second condition. The favorable condition for the formation of an ionic bond is that the non-metal atom should have higher value of electron gain enthalpy so that it can take up extra electron easily to form anion easily. Then I am not saying you have a target day. Non-metal atom to electron gain enthalpy ki value to solve whatever ni. Do it at the electron am not loxin mangame. I do not non-metal atom do. Magi size should pick it up. Electron am not loxin high target. And the second condition is that non-metal atom must have higher value of electron gain enthalpy. So higher value of electron gain enthalpy so that it can easily take up an oxide electron and forms anion easily. I'm like same name to the favorable condition with the silicon. So this is the second condition. The non-metal atom anion same in a non-metal atom must have higher value of electron gain enthalpy so that it can easily take up an oxide electron and forms anion easily. So this is the second condition for the favorable of ionic compound, ionic bond. The example of a take carbon metal atom no ionic bond same kind of favor to this kanda halogen atom since halogen atom. Halogens in the example the halogens have the or group 17 element. Group 17 elements halogens kana no fluorine, chlorine, bromine, iodine. Halogens non-metal atoms they can easily form ionic bond by the combination of non-metal atoms by the combination of metals like alkali atoms. Because these halogen atoms have higher value of electron gain enthalpy because of their smaller atomic size. Smaller atomic size be more periodic table ki right side tele nina atomic size to pick pako. Adana nangna ionic compound ama singe habata ionic bond ama singe habata ragati akuni easily koi halogen atoms singe local ko. Moise halogen atoms ga topa metal atom ko combine tawali kali marangin hoy kanda halogen atom magi small atomic size pick panina electron yam lai loxlaga and yam lai semanga manina magi electron gain enthalpy value sawi hibane ko. So this is the second condition for the formation. Second condition of the favorable condition of formation of ionic bond ko non-metal atom se electron gain enthalpy value wanga. The last two last point lattice energy. Lattice energy lattice energy. And in a high grade, the ionic compound form must have higher value of lattice energy, so that the ionic compound is more stable. The ionic compound same report to lattice energy value wangati ionic compound same to stable way. The lattice energy has a no hana we define to lattice energy have the let me give the definition. It is defined as the amount of energy release. It is defined as the amount of energy release when oppositely charged ions that is cations and anions to form 1 mole of an ionic compound. 1 mole of an ionic compound. So let me put it again. It is defined as the amount of energy released when oppositely charged ion cations and anion combines to form 1 mole of ionic compound. Haibako koigi oppositely charged ion cations and anion combine toroga 1 mole of ionic compound same kind release to energy to koi kowe kind lattice energy kowe habako. Actually, lattice energy say combine tholi no haitagati due to the electrostatic force of attraction between the cations and anion in the formation of ionic bond happening. The formation of ionic compound have koi ionic compound same kanda cation amasung anion marakta electrostatic force of attraction laibasna maram oiraga energy release tawdo kuna kai kowi lattice energy kowe. Adana higher the value of lattice energy, the ionic compound form will be more stable. Hibernate. Okay, karigumba lattice energy ki value to wamba taragati magi ionic compound similar to more stable or any have. Aduna the third favorable condition for the formation of ionic bond is that the ionic compound must have higher value of lattice energy. Ionic compound same photo higher value of lattice energy like since if the value of lattice energy is high, the ionic compound form is stable and it can easily form stable oirabanina ionic compound yam line semangamani haibanebako. So these are the favorable conditions for the formation of ionic bond. And last one I repeat okay. The favorable conditions for the formation of ionic bonds are number 1 point the metal atom must have lower value of ionization enthalpy so that it can easily lose valence electron to form cation easily. Point number 2, the non-metal atom must have higher value of electron gain enthalpy so that it can easily take up an oxide electron to form anion easily. And the last point, the ionic compound form must have higher value of lattice energy so that the ionic compound is more stable and can easily form higher favorable condition. Say pekhada tum hangmani ko 3 marks period. Ado koi si the matang asida roisilasi matang class tana what are the factor what are the factor that influence the value of lattice energy. Lattice energy the influence toriba lattice energy the influence lattice energy ki value the influence toriba factor mayam do matang class tana nerasi. Okay, asi woi lattice the roisilasi. Bye bye.